This is question 1 from the review for exam number 3. So we have a race car driving around counterclockwise on a circular track, and we have it starting at the 3 o'clock position. So it's a circular track. Car is here. We also know the circular track has a radius of 1.3 miles. And now we'll be able to answer the questions about this car as it moves. So how much distance in miles has a race car traveled if the angle that has been swept out is 3.4 radians? So for this question, now 3.14 radians, that would be pi, right? That would be, so all the way to the other side of the circle. 3.4 is going to be a little bit more than 3.14. I don't know, I'm going to do a sort of a guesstimate that it's from here, so the angle goes like this. 3.4 radians. And we have a formula that we can use. The arc length, which is how far it would trace out, is equal to r theta. So we have the r, which is 1.3. We have the theta in this case, which is 3.4. So s, which we're also going to later on, we would call that our distance, right? We use s because it is an arc length on this portion here. So it's how far the car went from here to over there. Is simply going to be 1.3 times 3.4. And when we come over to our calculator, we don't really have to worry about being in radian mode because we're not using a trig function at this time. We just have these numbers, 1.3 times 3.4. And we get 4.42, and that'll be in miles. Okay. What is the angle that has been swept out if the car traveled? 6.3 miles. So this one's going to use this same sort of formula, right? Except we know different things. We know the s, we know the distance, we still know the radius. That's not going to change on us. What we're trying to find is the theta. So let me just change over to using d instead of s, is equal to r theta. Divide both sides by r. So I now have a formula that theta will be the distance divided by the radius. And we're going to use that because that will help us with the following few examples. So the distance is 6.3 miles, right? The radius is 1.3 miles. Right, and miles are going to cancel out. We're going to be now in terms of radians. So we just come over here and 6.3 divided by 1.3. And again, for this particular calculation, we don't need to be in radian. We can be, but it's not critical. When we need to make sure we're either in radians or degrees depends upon if we're using a trig function. So we enter, and that gives us a not a distance, a radians, right? This is going to be 4.846. You can keep going, maybe 2. They don't tell us how many decimal places to put out, but that's radians. So, you know, if this is 3.14, it's going to be further down. Okay. Now we're asked to define a function that determines the vertical distance. So remember, vertical distance is the up and down. That's going to lead us into the sine function. If they wanted a horizontal distance, then we'd be looking at the cosine above the center of the track in radii in terms of the distance the race car has traveled on the track. So let's do a function, and what we're going to terms of the distance the car has traveled. So we're traveling a distance. And what's the vertical distance above the center of the track? That's going to be sine. And since it's in radii, not in miles, okay, so if it was miles, we would multiply by 1.3 in the front, but since it's in terms of the radii, what we're going to get is it will be the distance divided by the radius, which in this case is 1.3. Okay, so we could actually put that in there. I know in the answer key they just have R, but for this particular problem, we're told that R is 1.3 miles. I guess I should put miles here, right? So I'm going to do it this way. You'll see the answer key has D over R. That's okay, but this is better. Okay, so let's keep going. How many miles above the center is the car when the angle swept out is 2.1 radians? So notice, remember the input for a sine function is the radians. And what is it going to give us? How many miles above the center? So now this time we wanted in miles, not in terms of radii. So we're going to use this function, but we're going to multiply that function that we have there by 1.3. So we're going to take 1.3 times the function at 2.1, and let's just not even use that function, because what I'd have to input is the distance, which I don't have. Okay, so let's think in terms of another thing. Above the center, so that will be 1.3 times the sine of theta, right? Which is 1.3 times the sine of 2.1. So I don't have to do this thing. The distance divided by 1.3 is 2.1. That's what it's telling us. So we could calculate the distance by coming back what we did in question A, but we don't need to, because what they're asking for is how many miles above the center is it. So we use this. Okay, so now we definitely need to be in radian mode. So again, if you forget how to do that on a TI-83, you hit the mode button, and then there's radian or degree. Radian's blacked in, so we're good. If we need to switch to degree, we come over here, hit enter, but we want to keep it in radian, so we'll keep it there. I do second mode again, which gives us the quit, brings us back here. So it's just 1.3 times the sine of 2.1, and I'm in radian degrees, or radian mode. Can't do that. Okay, so there's our answer there. It is 1.122. If you go out that far, it's 7 rounded that one up. Okay. Finally, how many miles to the right of the center of the track is the car when the car has traveled 2 miles? So this is basically going to be the same thing that we did, except since it's to the right and not above, we're going to use the cosine function. And then we aren't given how many radians, right? Won't get to the next one yet. Let's give some room here. So we know it's traveled 2 miles, so we don't know the theta. So it's going to be 1.3 cosine, and we'll come back to our little friend up here. This was sine of d over 1.3. What we have for being to the right is going to be the cosine of d over 1.3. Okay, 1.3 is the radius, and in this case, d, the distance traveled, is 2. So we can put this in, and that will give us the answer, 1.3 times cosine 2 divided by 1.3. And there we are, not even a mile, not too far, haven't really gone. And again, again, this is how many miles to the right of the center of the track. Well, think of it, it's gone 4 miles. It's traveled 2 miles. And you could draw the picture if you needed to, but it's probably close. See, it's positive, right? So it's just a little bit to the right. Oops, 4. That's a 4, not a 9. 4, 2, which matches 0.042, 0.28. That'll match. And again, they're going to be, if we were to do this, it's slightly positive. It's going to be like someplace up in here, maybe even closer. So it's gone 2 miles this way, and that's where it should be. Okay. So that's question 1. We'll stop the recording now.